All right, welcome to module 2 or chapter 2 of the Cybersecurity Essentials course. All right, so which is Cybersecurity Cube. Okay, we'll look at CIA triad, the state of data, cybersecurity countermeasures, the IT security management framework. Let's look at the dimensions of the cybersecurity cube. So, the first dimension of the cybersecurity cube identifies the goals to protect the cyber world. So, the goals identified in the first dimension are the foundational principles of the cybersecurity world. All right, so the three principles are confidentiality, integrity, and availability. So the principles provide focus and enable cybersecurity specialists to prioritize actions in protecting the cyber world. So we can use the acronym, which is the CIA triad. So these are the three principles for cybersecurity. Then next, you also need to understand the state of data. So when data is being moved from one place to another, it actually changes in states. All right, and the three states of data is data at rest, okay, which is or in storage. So when the data is actually in a stored location, it is at rest. Data in transit, when data is being transferred from one location to another, it's data in transit. That's its current state. Then when data is being used, all right, the data is actually in process. Security, cybersecurity safeguards. So the third dimension of the cybersecurity cube defines the types of powers used to protect the cyber world. So the sorcery cube identifies the three types of powers, which is technologies, policies and practices, and people. So technologies include the devices and products available to protect information systems and fend off cyber criminals. Then policies and practices include the procedures, the guidelines that enables the citizens of the cyber world to stay safe and follow good practices. Then people are aware and knowledgeable about their world and the dangers that threaten their world. Now let's look more into the CIA triad. Let's look at confidentiality. The principle of confidentiality means that confidentiality prevents the disclosure of information to unauthorized people, resources, and processes. Or another thing for confidentiality is what privacy. So when something is confidential, it means it's private, right? So organizations need to train employees about best practices in regarding sensitive information to protect themselves and the organization from attackers. So there are different methods that are used to ensure confidentiality. It could be encryption, authentication, and access control. So protecting data privacy. Organizations collect large amount of data, and much of its data is not sensitive because it is publicly available, like names and telephone number. So other data collected though is sensitive. So sensitive information is data protected from unauthorized access to safeguard an individual or an organization. Then another is access control. So access control defines a number of protection schemes that prevent unauthorized access to whether a computer, a network, an office, right, a database, a data center, uh, or equipment. So the concept of AAA involves three security services. All right, access control could be authentication, authorization, and accounting. So that's what the AA has to talk about. So authentication verifies the identity of the user to prevent unauthorized access. So users provide their identity with a username or ID. Then authorization services determine which resource user can access along with the operations that users can perform. All right, so it's um, governs the different abilities a user or the different actions a user can carry out within a network or within an office, within an infrastructure. The another is accounting. So accounting keeps track of what users do, including what they access, the amount of time they access the resource, and whatever changes that they made. So this is actually what helps to track or used to track cyber attackers. So confidentiality and privacy seem interchangeable, but from a legal standpoint, they mean different things. So most privacy data is confidential, but not all confidential data is private. So access to confidential information occurs after confirming proper authorization. So financial institutions, hospitals, and medical professionals, law firms, and businesses handle confidential information. So confidential information has a non-public status. Maintaining confidentiality is more of an ethical duty. So privacy is the appropriate use of data. When organizations collect information provided by customers or employees, they should use that data for its intended purpose and not sell the data or use it for financial gain. Then let's look at integrity now. What the principle of integrity is about the accuracy, the consistency and trustworthiness of data during its entire life cycle. All right. So when the data is being stored, when the data is at rest, when it's on transit, and when it is in process, and when back to when it is what's being stored. Okay. So another term for integrity is what quality. So the methods that are used to ensure data integrity include hashing, data validation checks, data consistency checks, and access controls. So why is integrity needed? So data integrity varies based on how an organization uses data. For example, Facebook does not verify the data that a user posts in a profile. All right. So, but now when it comes to a bank, so bank or financial organization assign a higher importance of data integrity than Facebook does. So transactions that customers' account must be very accurate. If not, it could lead to financial loss or even loss of life. Protecting data integrity is a constant challenge for most organizations. So, loss of data integrity can render um, entire data resources unreliable or unusable. So, integrity checks are being performed, and those are ways to measure the consistency of a collection of data. All right, so data could be a file, a picture, or a record. So integrity checks performs a process called a hash function to take a snapshot of data at an instant in time. Lastly, in the CIA triad is availability. So availability is the principle used to describe the need to maintain availability of information systems and services at all times. So cyber attackers and system failures. Cyber attacks and system failures can prevent access to information systems or stop the provision of services that are being made by organization. So methods used to ensure availability include system redundancy, system backup, increased system reliance, resilience, equipment maintenance, up-to-date operating system and software or firmware, and plans to place to recover quickly from unforeseen disaster. So high availability systems typically include three design principles: eliminate single point of failure, provide a reliable crossover, and detect failures as they occur. So organizations can ensure availability to by implementing um, equipment maintenance, OS and system update, test backups, plan for disaster, implement new technologies, monitor unusual activity, test to verify availability. Now let's look more deeply into the state of data. So we are going to look at data at rest, data on transit, and data in process. So data at rest is actually stored data. So which means that data is stored and is not being used at that particular time. So a storage device can be local on a computing device or centralized on a network. So a number of options exist for storing data. So direct attached storage is storage connected to a computer, a hard drive or USB flash drive, and is an example of a direct. Those are examples of direct attached storage. So in data at rest, we have a redundant array of independent disks, which is RAID. So RAID use multiple hard drives in an array, which is a method of combining multiple disks so that the operating system sees them as a single disk. So RAID provides improved performance and fault tolerance. I think you need to go and search more about RAID because there are different kinds of um, RAIDs. I mean, there's level 0, there's 0 to up to 5, right? So a network attached storage device is a storage device connected to a network that allows storage and retrieval of data from a centralized location by authorized network users. So, network attached storage devices are flexible and scalable, meaning administrators can increase the capacity as needed. Now, this is how the cloud works, alright, because the purpose of the cloud is for scalability primarily. So, the scalability and availability actually. So, the storage area network architecture is a network-based storage system. So the system connects to the network using high-speed interfaces, allowing improved performance and the availability to connect multiple servers to a centralized disk storage repository. Then now, data in transit. Data transmission transition involves sending information from one device to another. So there are numerous methods to transmit information between devices. It could be sneaker nets, so use removable media to physically move data from one computer to another. We have wired networks, so that's using cables to transmit data, which have practicalized that in packet tracer or even physically. Then we have wireless network, which is going to use the airwaves to transmit data. So the protection of transmitted data is one of the most challenging jobs of a cybersecurity professional. The greatest challenges are protecting data confidentiality. Right, so cyber criminals can capture, data, save and steal data that is in transit. So protecting data integrity is another challenge. So cyber criminals can intercept and alter data in transit, and also protecting data availabilities is another challenge because cyber criminals can use rogue or unauthorized devices to interrupt the availability of data. The last or the third stage of data is data in process. So this refers to data during initial input, modification, computation, or output. So protection of data integrity starts with the initial input of data. So organizations use several methods to collect data, such as manual data entry, scanning forms, file uploads, and data collection from sensors. So each of these methods pose potential threats to data integrity. And data modification refers to any changes that has been made to the original data, such as users manually modifying data, programs processing and changing data, and equipment failure resulting in data modification. So processes like encoding or decoding, compression and decompression, and encryption and decryption are all examples of data modification. So malicious codes can also result in data corruption. Let's look at cybersecurity countermeasures. So there are different technologies that can be used in cybersecurity. Let's look at the software-based technologies. So software safeguards include programs and services that protect operating systems, databases, and other services operating on workstations, portable devices, and servers. So there are several software-based technologies used to safeguard organizations' assets. Then hardware-based technology safeguards are also available. So they could be appliances that are installed within the network infrastructure or the network faculty. So they can include firewall appliance, intrusion detection systems, or intrusion prevention systems, and content filtering systems. So let's look at the network-based technology safeguards. So technology countermeasures can also include network-based technologies. For example, the VPN. So the VPN is a virtual private network, okay, that uses public network, all right, that uses the internet. So the security of a VPN lies in the encryption of packet content between the endpoints and define the VPN. So the security of VPN is just lies in the encryption of those packets that are being transmitted between the two different endpoints. So we also have network access control. So it requires a set of checks before allowing a device to connect to a network. We also have wireless access point security, which are implemented on access points, okay, in order for to prevent users from connecting to the network with the wrong security key. We also have cloud-based technology, all right. So technology countermeasures now also include cloud-based technology that shift technology components from organization to the cloud provider. So we have software as a service, which is SaaS, which allows users to gain access to application software and database. We have infrastructure as a service, provides virtualized computing resources over the internet. The provider host and hardware, software servers, and storage company. We also have virtual security appliance, which run inside a virtual environment with a prepackaged hardened operating system running on virtualized hardware. Implementing cybersecurity education and training. So a security awareness program is extremely important for an organization. An employee may not be purposefully malicious but just unaware of what the proper procedures are. All right. So there are several ways to implement a formal training program. So make security awareness training a part of employees onboarding process, tie security awareness to job requirements and performance evaluation, conduct in-person training sessions, complete online courses. So security awareness should be an ongoing process since new threats and techniques are always on the horizon. Cybersecurity policies and procedures. So a security policy is a set of security objectives for a company, okay, that includes rules of behaviors of users, administrators and specifies system requirements. So these objectives, rules and requirements collectively ensure the security of a network, or the security of the data and the security of the computer systems that are within the organizations or that are on the network. Then we also have standards. So standards help an IT staff maintain consistency in operating the network. So standards provide the technologies that specific users or programs need in addition to any program requirements or criteria that an organization was what follow. So we also have guidelines. Guidelines are a set of a list of suggestions on how to do things more efficiently and securely. So they are very similar to standards, but are much more flexible and are not usually what mandatory. We also have procedure. So procedure documents are longer and more detailed than standards and guidelines. So procedural documents include implementation details that usually contain step-by-step instruction and graphics. The IT security management framework. So looking at the first one, the ISO model, all right, the International Organization for Standardization. So security professionals need to secure information from end to end within the organization. So this is a monumental task, very important, and it is unreasonable to expect one individual to have all the requisite knowledge. So the ISO and the International Electrotechnical Commission, which is IEC, developed a comprehensive framework to guide information security management. So the ISO cybersecurity model is to cybersecurity professionals with the OSI networking model. I'll come again. The ISO cybersecurity model is to cybersecurity professionals what the OSI networking model is to network engineers. So both provide a framework for what understanding and approaching complex tasks. So we did the OSI model in the networking essentials classes. So the ISO IEC 27000 is an information security standard published in 2005 and revised in 2013. So the ISO publishes the ISO 27000 standards. So even though the standards are not mandatory, most countries use them as a de facto framework for implementing information security. And some of these standards have risk assessment, security policies, compliance, business continuity management, access control, human resource security, physical and developmental security, and several other items within them. So the ISO 27000 is a universal framework for every type of organization. So in order to use the framework effectively, our organization must narrow down which domains, control objectives, and controls apply to its what environmental operations. So the ISO 27001 control objectives serve as a checklist. So the first step an organization takes is to determine if these control objectives are applicable to the organization. So the ISO cybersecurity model and the state of data. So how do we use this? All right. So different groups within an organization may be responsible for data in which in each of the various states. So, for example, the network security group is responsible for data during transmission. Programmers and data entry people are responsible for data during processing, and hardware and server support specialists are responsible for data in rest. All right. So the ISO control specifically addresses what security objectives for data in each of these its three states. So the ISO 27001 control objectives relate directly to the organization's cybersecurity policies, procedures, and guidelines, which upper management determines. So it's also the ISO 27002 controls provide technical direction. So, for example, upper management establishes a policy specifying the protection of all data coming in or out of the organization. So, implementing the technology to meet the policy objectives would not involve upper management. So, it is the responsibility of IT professionals to properly implement and configure the equipment used to fulfill the policy directives set by upper management. So we've come to an end of this chapter. We've looked at the CIA triad and um, the three states of data. Okay, we looked at the three dimensions of the cybersecurity source cube. Okay, and also look at some standards and how the ISO standard is important at every point in the data cycle, which is data at rest, data on transit, and data in process.